Vieta's formulas. So far, we have had the quadratic equation given and the task was to find the roots, if any. Now, we are going to consider a quadratic from the inverse point of view, i.e. to find the coefficients and constant of the original equation when the two roots are known. For this, we have to use two formulas, known as Vieta's formulas. Thus, if the roots of a quadratic equation are x to the power of 1 and x squared, the coefficients are a and b, as usual, and the constant of the equation is c, then Vieta's formulas are as follows. 1. The root sum formula. We have the following as shown on screen. 2. The roots product formula. We have the following as shown on screen. Proof. For the first formula, we have based on the quadratic formula, we have the following as shown on screen. And for the second formula, we have the following as shown on screen. Example 1. The two roots of a quadratic equation are -1 and 3. What is this equation? Solution 1. From Vieta's formulas, we can write the following as shown on screen. We can write the following as shown on screen. Therefore, since all quadratic equations have the form, we can write the following as shown on screen. We can substitute b and c in terms of a, using the relations found through Vieta's formulas. Thus, we obtain the following as shown on screen. Dividing both sides by a yields, we obtain the following as shown on screen. Hence, simplifying by a, we obtain the original quadratic equation, we obtain the following as shown on screen. You can find the proof by calculating the roots of the last equation. If you follow all steps carefully, you will obtain the root x to the power of 1 equals -1 and x squared equals 3, as given in the clues. Another example to better clarify this point. Example 2. The sum of the roots in a quadratic equation is -7 and their product is 6. What are the roots? Solution 2. From Vieta's formulas, we have the following as shown on screen. We have the following as shown on screen. Writing the quadratic equation in terms of a yields, we have the following as shown on screen. Simplifying the coefficient a from all terms yields, we have the following as shown on screen. Now, we can use the quadratic formula to calculate the roots. Given that a equals 1, b equals 7 and c equals 6, we first calculate the discriminant, i.e. we have the following as shown on screen. Hence, the two roots are shown in the following on screen. We have the following as shown on screen. In other cases, it may be very useful to raise the clues in the second power to obtain useful info in a much shorter way than previously. Vieta's formulas are very helpful in this regard. Let's consider an example to clarify this point. Example 3. The sum of the two roots in a quadratic equation is 2 and their product is -3. What is x to the power of 1, 2 plus x squared, 2? Solution 3. From the clues, we have the following as shown on screen. Raising both sides in square yields, we have the following as shown on screen. Again, from the clues, it is known that x to the power of 1x squared equals -3. Therefore, we have the following as shown on screen. Hence, we have the following as shown on screen. That is all for lesson 9.6.4, and the end of tutorial 9.6. To continue this chapter, please watch 9.7, Introduction to Systems of Linear Equations. Methods for solving them. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.